Okay guys, here is the application for the electromagnetic radiation part of the course. Here we have the happiest pink plane on the planet. He's a LADS plane, or she's a LADS plane, and what this plane is going to be doing is shooting a laser downwards. So LADS stands for Laser Airborne Depth System. And what that means is you can determine the depth of a part of the ocean. So here's my fancy ocean. I haven't drawn any fish. Maybe we'll fix that. You know, there's a fish and there's another fish and stuff like that. Alright, so here's some fish in the water. We're not going to hurt them, don't worry about it. But what we are going to do is shoot a laser beam down at the ocean. And it works up to 40-ish meters, I guess. So it's not going to work, deep ocean trenches like where Megatron got dropped in the original Transformers movie. However, it does work. It's really good for ocean mapping, especially close to the shore, sandbars, sandbanks, that sort of thing. So what we're going to be able to do is shoot a laser straight down. So our laser beam goes down, hits the surface of the water. Now, water is a reflective surface, but not completely reflective. So some of that laser beam is actually going to get reflected. So what we have is a partially reflected beam or pulse from the surface of the water, goes back to the plane and starts a stopwatch. A really, really good stopwatch. Now, another thing that happens is, seeing as this is only a partially reflective surface, some of the beam actually gets through the water and goes on to the bottom, or a fair bit of it, some does. So we have partially, part of the beam goes through the water and reflects off the ocean or the sea floor. Now, depending on the depth is, I guess if it goes too deep, you're just not going to be able to see the dot on the bottom of the water. Remember, this is you shining a laser down to the bottom of the water, and the only way you can detect it is if you can see it. So if it's really deep water, you're not going to be able to see it very much. If it's really cloudy water, murky water, whatever, you're not going to be able to see much. So the bit that reflects off the ocean sea floor is minimal because of scatter, and absorption by other things in the ocean. So what we're going to do now is assume that we've got a bunch of the beam coming back up. Gets to the surface of the water, and some again is reflected off the undersurface of the water, but we're going to ignore it. The rest is passed back to the plane. And we have the secondary beam just here detected at the plane, and the clock stops. So now what we've got is two timestamps. We have the time that the original beam got pulsed back to the plane, and we have the time that the secondary beam got pulsed back to the plane. So what we can do is get T to take T1. So this would be T1, this would be T2. So we have some sort of time difference. This time difference is like both beams have gone from here to here, so both beams have done that, and both beams have also gone back up to the water, back up to the plane. So the time is literally just for this part here. Alright, so that's the only difference in the time, so that's the only difference in the depth or the distance that they've travelled. This here is used along with the speed of light in water. It's a little bit less than the speed of light in air. For ocean water, some rivers and stuff, it's about 2.24 by 10 to the 8, not 3 by 10 to the 8 like it is in a vacuum. Depending on the density, I guess, of the liquid, it's a little bit more, a little bit less. And we've also got a distance that we can measure. So S equals VT, one of the simplest forms of calculating distance is V by time. And in this case here, we can rearrange it to get the depth is that speed times half the time it took. So we've got from the top to the bottom and back up, we only want half that distance to get the depth. Okay, so we only want the time it takes to travel that part, which isn't the whole time, it's only half the time. So using this equation here, we can very quickly calculate the time that it takes here. Now we need a high power laser, or lots and lots and lots of photons. because we have a lot of reflection and scattering and all that sort of stuff. So if we send a bajillion of photons down, we're hoping to detect a couple 100,000 on the way back up, and that's enough to measure the depth of the ocean at that point. These pulses can be sent, 10, 20, whatever it is, times per second, so you can actually measure it really, really accurately as you're going along.